Now let's take a very good question. It says that we have to find the number of integral points within the graph of this, that is mod of x minus 2 plus mod of y plus 6 is less than equal to 8. There are two approaches of solving this question. One is directly applying the shortcut formula, which is if we have been given, say, x minus a plus y minus b is less than equal to n, where a, b, n and n are integers, then straight away the number of solution for the same is given by the shortcut formula, that is 2n, n plus 1 plus of 1. So this is the shortcut formula. You can directly substitute the value of n is equal to 8 here, because it is independent of a and b, and I'll tell you the reason for the same. But if you want to get the answer, you can directly put the value of n is equal to 8 for this question and get the answer. But I would like to discuss this question at details so that we can solve the question or a similar kind of questions at ease. So if I substitute, I do not want these 2 and 6 to hinder my solution. So what I'm doing is here is I'm substituting the value of x minus 2 to be capital X and y plus 6 to be equal to capital Y. So the corresponding values of x and y, the number of corresponding value of capital X and capital Y will be the corresponding value of small x and small y. For example, if I take, say, x is equal to 2 is one of the solution and capital Y is equal to 6 is one of the solution, then the corresponding value of small x would be 4 and 0 respectively. So it doesn't matter, because we don't have to find the values, we have to find the number of values. So I can easily substitute, or I can write this as capital X plus capital Y less than equal to 8. Again, just to simplify the question, I just want to get the integral solution of this expression. Say capital X plus capital Y, the mod of capital X plus capital Y is equal to 8. How many integral solution this particular expression will have? Because this will guide us to get the solution of the given question. Now if I want to write all the solutions, what I can do is I can take, let me assume that both x and y are non-negative number. So I can assume capital X and y, and I want to write all the possible solutions here. So I can take x is equal to 0, so the value of y has to be 8. Similarly, if I take 1, it will be 7. If I take it 2, it will be 6. If I take 3, it will be 5, 4, 4, 5, 3, 6, 2, 7, 1 and 8, 0. Here I have discarded the negative value of x and y, but that will also be the part of the solution. Now if you observe, from the second pair to the second last pair, both the values are non-negative, or in fact positive number, I would say. And each of these pair will give me the corresponding 4 pair of x and y. So I can have plus minus 1 and plus minus 7, that is the value of x and y, or the pair would be 1 7, minus 1 7, 1 minus 7 and minus 1 minus 7. Similarly, the same thing can happen with the third value, the fourth value, and so on and so forth till the second last number. So the number of solution, or the number of pairs, the positive pairs are 1, 2, 3, 4, 5, 6 and 7. So if I want to count the corresponding all integral solution, I can say that it will be 7 into 4. For each of this pair, I have corresponding 4 pairs, something like this, which will be the solution. Now the solution which contains exactly 1 0, each of this pair will give me 2 possible pairs, or 2 possible integral pairs. So if I take 0 and 8, so I can have 0 and minus 8 as also the solution. Similarly 8 0, if I have 8 0, then minus 8 and 0 is also the possible solution. So the 2 solution for this and 2 solution for this, so it will be 2 into 2. Now if I write it down, it will be 7 into 4 plus 4, or I can write it as 4 into 7 plus 1, or is equal to 4 into 8. Now observe the pattern here. The value, the mods are equal to 8, and the corresponding solution, all integral solution, comes out to be 4 into 8. Similarly, had it been 7, it would have been 4 into 7, so and so forth. So unless till mod of x plus, or I can generalize that if mod of x plus mod of y is equal to n, where n is greater than 0, number of integral solution is given by 4 into n. So this we can generalize. And what about if it is equal to 0? Then it's pretty easy to find out that if mod of x plus mod of y is equal to 0, so there is only one possible pair, that is 0 0. Correct? Now coming back to the question, so I can, since I have generalized the things, so for mod of x plus mod of y less than equal to 8, I can consider this as all the possible solution of this expression can be considered as by equating this mod with 8 and getting the solution, then equating this LHS with 7 and getting all the solution till 0, and we'll add all the solution there. So we know that for 8 the number of solution will be 4 into 8, and if this mod is equal to 7, the number of solution will be 4 into 7, so and so forth, till the number is not equal to 0 or greater than 0. So I can say, barring this expression equal to 0, the solution, the sum of all the solutions will be 4 into 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which comes out to be 4 into 8 into 9 divided by 2, which is equal to, this goes by 2, so 16 into 9, it is 144. So this is the total of all the pairs such that mod of x plus mod of y is less than equal to 8 and not equal to 0. And for equal to 0, that we know that if mod of x plus mod of y is equal to 0, so then only one solution, which is 0 0. So adding these two numbers, the possible solution, integral solution, is 145.